This should not work. I am trying to machine a 4mm thin gib that is far longer than my milling vise. And that means one thing: flex, vibration and chatter. Normally, this kind of setup ruins the part completely. But this time, it didn't. I used a simple tool that completely changed the result. The problem is not just that the gib is thin. It is also long enough that it hangs far outside the vise on both sides. As soon as the cutter touches the material, the ends can flex away. Even with light cuts, the tool pressure is enough to bend it. And once that starts, everything goes wrong. You get chatter marks, uneven thickness, and a gib that will never sit properly. The middle ends up thinner, the ends stay thicker, and the surface finish is ruined. The obvious solution is to support the ends with machinist jacks. That sounds good until you think about what is really happening. Now the workpiece is supported in only a few points. Between those points, it can still flex. So instead of one problem, you now have several: high spots, low spots, and chatter marks in between. That is not a solution. That is just a different kind of failure. There had to be a better way. Something simple, rigid, and easy to set up. And then I noticed something. The offcut from the original cast iron stock looked exactly like a giant parallel. Long, straight, and almost the perfect size. If I could machine this into a proper parallel, it could support the gib along its entire length. No gaps, no flex, no vibration. I mounted the offcut in the vise and milled one side flat. Then I flipped the workpiece and squared the remaining faces. Each face is cleaned up carefully, removing the rough surface. I face one side to establish a reference. Then flip it over and bring it to length. At this point, I have a rough parallel blank, but it is not precise yet. Now the real work begins. I mounted the workpiece directly onto the milling table. It is clamped at both ends, leaving the faces free to be machined. The goal here is not speed, it is straightness. I take a light pass along the full length of the workpiece. You can see the cutter just starting to clean up the surface. Then I return along the same path, this time climb milling. I keep the cutter at the same depth for each pass. This reduces the effect of tool pressure and deflection. With each pass, the cut becomes lighter. I alternate between conventional milling and climb milling, gradually removing only the eye spots. Eventually, the cutter stops removing material completely. At this point, the face is now as straight as the x-axis of the milling machine can produce. Without unclamping the workpiece, I move to the opposite side. The setup stays exactly the same, only the cutter position changes. Again, light passes along the full length, alternating between conventional and climb milling, keeping everything consistent. Because the workpiece was never moved, these two faces are now not only flat, but parallel to each other. Now I rotate the workpiece 90 degrees and repeat the exact same process. Light passes, full length cuts, alternating directions, each pass refining the surface a little more. This creates a fully machined block. But there is an added benefit here. The width and height are different, so depending on how I place it in the vise, this one block can act as two different parallels. That makes it far more useful in the workshop. Now it is time to use it. I place a small parallel in the vise, then set the long support parallel on top of it. Because it extends far beyond the vise, any small error will be amplified at the ends. So I mount a dial indicator in the spindle, I lower it onto one end of the parallel and zero it. Then slowly move the table across, watching the needle carefully. From one end to the other, the variation is within 0.02 millimeter. That is more than good enough for this job. Now the Gib blank goes on top of the support parallel. It is clamped firmly in the vise. But this time, the entire length is supported underneath. I begin machining it down to thickness, taking steady passes across the surface. You can see the cut is clean and consistent. No vibration, no movement. As I approach the final dimension, I take a light finishing pass. This cleans up the surface and improves the finish. The Gib is now at 4 mm and more importantly, it is parallel along its entire length. Now comes the more difficult part, machining the thin edges. This setup is extremely unstable. The Gib is thin, long and barely supported by the vise. And here you cannot use supporting jacks, even if you wanted to. But the support parallel changes everything. I push it firmly against the back jaw of the vise. This effectively extends the support surface. Now, when I place the Gib against it, it has solid backing along its full length. I start cutting from the right side. The rotation of the end mill pushes the Gib into the support parallel, not away from it. That keeps everything stable. I take a 0.5 mm cut. No chatter. Then I flip the Gib over, and this time I go deeper. A 1.5 mm cut. Still no chatter. Without the support parallel, this would not be possible. With the edges complete, I square one end of the gib. Then bring the other end to length. Clean, straight and consistent. This is not the finished gib yet. The angles and final fitting will come later, as part of the cross-slide rebuild. But this was the critical step. Solving the problem of machining a long, thin part without chatter. And in the process, creating a simple tool that will be useful for many future projects. If you found this useful, vote for this idea. And check out the next project on screen.